So what are the different parts of X-ray tube? An X-ray tube functions as specific energy converter, so receiving electrical energy and converting it into two other forms of energy, the X-radiation that accumulates 1% and the heat, 99%. Heat is considered the undesirable product of this conversion process. Therefore, X-radiation is created by taking the energy from the electrons and converting it into photons. This very specific energy conversion takes place in an X-ray tube. So, the major X-ray tube components are the cathode and anode assemblies. So, the tube envelope, the rotor, and the stator. So, for rotating anode system, and the tube housing. These X-ray beam characteristics are important because they affect radiologic parameters such as spatial resolution, image contrast, and also patient dose. So, external parts of the X-ray tube are tube support, glass metal envelope, protective housing. For internal parts, we have cathode that includes filament and focusing cup, anode that has the stem and target, and also the rotors and bearings. So what are the functions of each part? So X-ray tube and housing assembly are quite heavy, so and therefore require a support mechanism so that the radiologic technologists can support it. There are three methods of X-ray tube support: ceiling support system, floor to ceiling support system, and CR support system. The outside of an X-ray tube is the tube housing. Within the housing lie an oil-filled glass envelope. So the X-ray anode, filament, cathode, and focal spots. Tube housing. This is the metal protective housing that encasing the X-ray tube. When X-rays are produced inside of the X-ray tube, they travel outward in all directions as shown in the drawing below. So, glass envelope, the glass envelope lies within the tube housing. So, it surrounds the components of the X-ray tube including anode and cathode. So, the glass envelope is made of Pyrex glass to withstand enormous amount of heat. So, as the glass ages or damaged, it loses its vacuum and becomes glassy. Air gets inside the vacuum tube. So, X-ray productions fall off drastically and the tube fails. So, another target, the target of the anode is the area where the stream of incoming electrons, tube current, actually slumps into the anode as they leap across the cathode. So, the surface of the target is made of tungsten steel to withstand enormous heat, while the rest of the anode is made of copper. Cathode, this is negatively charged side of the X-ray circuit. It is the power supply to the X-ray tube, providing incoming electrical current or tube current that will be converted into X-rays. So, the cathode has two main parts, filament and focusing cup. Filaments are coils of wire similar to the heating elements inside of a toaster. So, most are 2 millimeters in diameter. So, by 2 cm long. So, when electrical current passes through the filament, it heats incandescence to a white-hot temperature. So, focusing cup, on the other hand, is a metal shroud surrounding part of the filament that direct the stream of electrons towards the anode or target. Without a focusing cup, the electron stream would spread out and many of the electrons would miss the target altogether. So, focal spot, this is the area along the surface of the target from which X-rays are emitted. When a stream of electrons leap across from the cathode and collide with the target, this is smaller the focal spot, the sharper the resultant image. So, however, as the size of the focal spot decreases, more heat is concentrated onto a smaller area of the target. So, rectifiers are used in the complex process of converting incoming alternating current, so supplied from the power company to the direct current, because X-ray machines require direct current to produce a consistent output of X-rays. So next is, what does thermionic emission mean and where does phase charge happens? So thermionic emission is the emission of electrons from a heated metal or cathode. So this principle was first used in college tube and then later in modern X-ray tubes. So before the discovery of the principle, gas tubes were used for X-ray production. The cathode has its filament circuit that supplies it with necessary filament current to heat it up. As the temperature increases, the surface electrons gain energy. The energy acquired by the surface electrons allows to move a short distance of the surface, thus resulting in emission. So, a pure tungsten filament must be heated to a temperature of 2,200 degrees Celsius to emit a useful number of electrons. So, these electrons emitted from the surface are limited by the space charge effect. So, space charge effect refers to the collection of electrons which are emitted from the metal surface. So, after the application of the tube current a short distance away from the metal surface. So, these electrons collect and form a cloud of negative charge around the metal surface. So the space charge repels and limits the further emission of electrons from the surface and is referred to space charge effect. So the effect is most noticeable at lower kBp. So what are the types of focal spots? The focal spot is the area of the target from which X-ray is emitted. So radiology requires small focal spots because the smaller the focal spot, the better the spatial resolution of the image. So unfortunately, as the size of the focal spot decreases, the heating of the target concentrated onto a smaller size or smaller area. So this is the limiting factor to focal spot size. There are usually two focal spots. Most diagnostic X-ray tubes have two focal spots, one large and the other small. The small focal spot is used when better spatial resolution is required. The large focal spot is used when larger body parts are imaged and when other techniques that produce high heat are required. So selection of one or the other focal spot is usually made with the MA station selector, approximately 300 MA or less. So at approximately 400 MA and up, only the larger focal spot is allowed because the heat capacity of the anode could be exceeded if this small focal spot were used. The small focal spots ranges from 0.1 to 1 mm or millimeter. Large focal spot ranges from 0.3 to 2 millimeter. So each filament of a dual filament cathode assembly is embedded into the focusing cup. So the small focal spot size is associated with the small filament and the large focal spot size with the large filament. So an electric current is directed through the appropriate filament. So that's it for our different functions of the X-ray tube.